Hey guys, today we're going to be looking at graphing motion, but this time we're going to be graphing motion with projectiles. And a projectile is any object that's in free fall, so only gravity is acting on it. There's no other forces, nothing else is touching it, it's just falling with gravity. And last week we did actually look at that. We looked at this in free fall. But our free fall questions were always about something going strictly vertically, okay? Always straight up and down. Today, we're going to start looking at exploring the two-dimensional version of this, which is called projectiles. And a projectile is something that's falling, but it's also moving horizontally as it falls. So it's got two components of its motion, two different dimensions. So it's going to be two-dimensional motion. And those two dimensions are the horizontal and vertical dimensions. So horizontal obviously goes side to side, and vertical goes up and down. Now, last unit we looked at the directions for motion being in the positive direction and the negative direction. And that idea still applies here. But there's going to be a positive and negative for both horizontal and vertical. So typically, we say on a horizontal number line that going to the right is positive and the left is negative, and going up is positive and going down is negative. That's typically how the coordinate system is defined for like regular Cartesian coordinates in math. And in physics, you can do this, or you can choose whichever directions to be positive and negative that you like. It does not matter. It's entirely up to you. But each dimension, vertical and horizontal, is going to have a positive direction and a negative direction. The important thing is to make sure that you define them beforehand so that you know what choice you have made and that you stick with it while you work any problem so that you always know which direction something's going in. Now, it's easy to think about two-dimensional motion and to get slightly overwhelmed thinking about how we're going to deal with those both at the same time. And the great thing about the way that physics is built, the way that it's set up mathematically, is that we can consider each direction completely separately. So when you're analyzing an object that moves both horizontally and vertically, you can look at each part of that separately as if they aren't related at all. You can look at just the vertical part and just the horizontal part. To think about this idea, we're going to do this example together. We're just graphing for today. We're not actually calculating anything yet. That's going to come tomorrow. But we're going to consider this graphically to figure out what's going on. And before we consider anything, before you ever consider a problem, you have to define your coordinate system. And the way that we usually define it is by drawing a regular set of axes, horizontal and vertical. And here I'm going to define mine as most people normally would, with positive being to the right, negative being the left, positive being up, negative being down. However, you can define your coordinates however you like. It'll just change your graphs and the direction that they go if you choose differently. So our graphs here that I have set up are, we have 2 for horizontal and 2 for vertical. And these are going to be the same types of graphs as we looked at last unit. We're going to have position versus time. Those are going to be our top graphs. So this is position versus time. Same thing for the other side. And then the bottom one's going to be velocity versus time. Now, to differentiate between horizontal and vertical, we're going to be using a little bit different notation. Last unit, we said position is x, and change in position is delta x. We're going to use that same notation for the horizontal direction here, but the vertical direction we're going to denote as y, so that we can differentiate between the two. And this makes sense based on the x-axis and the y-axis that we use in math. Now, for velocity, and both of these axes are time. For velocity, however, we're still going to use v for both variables, but we're going to use a subscript to distinguish between the two. So have a v sub x and a v sub y. V sub x is velocity in the x direction, velocity horizontally. And in the vertical direction, v sub y is going to be the velocity going in the y direction. Okay, now that we've got everything set up, let's actually consider what's happening in our question or our example. It says, you are standing on a cliff that is 10 meters tall. You kick a pine cone straight off the edge, going 10 meters per second. Graph its motion in each dimension below. So, first thing I'm going to do here is draw a little picture, okay? So here's going to be my cliff and my person. That's an awkward person kicking the pine cone. Okay, that's my pine cone, and it falls down to the ground. Goes kersplat, okay? So something that I need to do is go ahead and set my origin. And I know which direction is what, but I'm going to set my origin as the bottom of the cliff right here, okay? So as my object goes, it's going to move in the positive direction horizontally, and it's going to move in the negative direction vertically. But it starts off above 0 vertically, and it starts off at 0 horizontally. Like if you were going to write this starting position here as a point, it would be 0 for the x value, the horizontal, and then let's see, 10 meters for the vertical, because we're standing on a cliff that's 10 meters tall, okay? So if we look at this graphically, we can consider these directions separately. We're only going to consider the horizontal first, okay? So my horizontal position started off at 0. And then my dude here, or me, if it's the question, kicked this pine cone off, and it started to move to the right. So at the end of its fall, it ended up right there, and it had moved over to this position that's more on the positive side, a positive position. So my delta x was positive. Now there's a question here, and this question is going to be fundamental to a lot of projectile motion, and it's hard to explain the answer to without going into some Newton's laws that we're going to learn later. But the question is whether the pine cone, as it went horizontally, if it sped up, if it slowed down, if it stayed the same velocity, only in the horizontal direction. Now the y direction is a bit more intuitive, and we'll get to that in a second, but horizontally, as it goes through the air, there is nothing pushing it to the left or to the right. I mean, after you kick it, after it's already left the cliff, there's nothing to push it and speed it up, because gravity is only acting in the vertical direction. Right now we're only looking at horizontal. So this graph is going to be one of constant velocity. It doesn't speed up or slow down in that horizontal direction. That's what our position time graph is going to look like. And then the velocity time graph is going to be a constant velocity in the positive direction, because we're going towards the positive side. So we have a constant positive velocity, and it is given to you in the question as 10 meters per second. Now on the vertical side, things are a little bit different. Vertically, we start off at 10 meters. Okay, so we start off up here. And our object is going to fall downwards in the negative direction all the way to 0. So we're going to end up over here. But as it falls, gravity is pulling on it. And if gravity is pulling on it, it is going to start speeding up. Okay, it's going to start speeding up. So we start off slow, and actually we start off from rest. And we speed up as we go down towards 0. Sorry, my graph isn't very smooth there, but we are speeding up. Now the velocity graph is going to mirror that, and our velocity is going to be on the negative side, because we're moving down in the negative direction. If you look at your position time graph, it's definitely moving down. So we're going to start off with a 0 velocity. And we're going to get faster, but we've got to be on the negative side of that graph. So we go faster in the negative direction. And there's our velocity versus time. So our acceleration in the x direction was 0 because the slope of our velocity graph is 0 and it's not speeding up or slowing down. But in the vertical direction, we are accelerating. Our acceleration is equal to gravity, 9.8 meters per second squared. And it's a negative this time because gravity is going down, and we chose down as negative. So that is projectile motion in a graphical nutshell. Today, what you're going to be doing is a Vernier video analysis. That assignment is in Google Classroom. It's kind of a lab. But if you are at home and you either can't video it, you don't have a meter stick, whatever the issue is, you can either use the video that Miss Kakanis attached to the assignment that she pre-filmed. You can use that one, or you can use the one of the guy shooting a basketball that is already available in Vernier. That is up to you. For in-person kids, you're definitely going to be throwing some balls across the room. Anyway, hope this video was helpful. If you need some help, my physics office hours are on Mondays from 9:45 to 10:30. You can find that link in Google Classroom. But please let me know if you need any help. Otherwise, get working on your lab.